For years, we've all watched AI get incredibly good at sight and sound, right? It can pick a face out of a crowd, it can transcribe our conversations, it can even compose music. But now it's starting to tackle a sense that's way more ancient and, let's be honest, completely underrated, our sense of smell. And there's a real irony here. A survey from McCann World Group found that almost half of young adults would literally give up their sense of smell before they'd lose their phone. I mean, think about that. We value it so little. And yet, this very same forgotten sense is becoming a massive new frontier for technology. So that raises the big question, doesn't it? Why are researchers and startups all of a sudden obsessed with teaching machines how to smell? Well, the answer starts not in some high-tech lab, but in a kitchen. And it ends with applications that could seriously change all of our lives. Okay, so this whole journey kicks off in a pretty surprising place, not in a multi-million-dollar R&D facility, but with something we can all relate to, the quest for better home-baked bread. So meet Benjamin Cabet. During lockdown, like a lot of us, he got really into baking sourdough. But he had this unique, kind of nerdy question. Could he use AI to figure out if the smell of his sourdough starter was a good predictor for how the final loaf would turn out? What started out as just a fun weekend project became a perfect entry point into this whole world of digital smell. And the process he used just goes to show how accessible this technology has become. This isn't science fiction anymore. Cabet used a simple $30 development kit and a basic gas sensor to capture the chemical fingerprints of different smells. Coffee, whiskey, just the regular air in his room. Then he just had to label that data, and he used an online platform to train a simple AI model to tell the difference. And right here, this is the core advantage. Our sense of smell is subjective, right? And our noses get tired. It's a real thing called olfactory fatigue. And AI knows, though, it's just pure, unbiased data. It's consistent, and it never gets tired. As one CEO put it, your nose cannot smell something for 24 hours continuously. Our device can. And that single capability is what's unlocking massive industrial applications.
Okay, so let's see how this idea jumps from a hobbyist's kitchen to the factory floor, where smell is a very, very serious business.
Take a French startup called Bell, for example. They've raised over $19 million from huge companies like Hyundai to build these sophisticated platforms that can detect and recognize scent data from major industries. So yeah, we are way beyond a weekend project now. This is a serious market.
And the applications are just so practical. In the perfume industry, they use it to track how a fragrance changes over a full day. For a car company like Hyundai, it means maybe detecting the faint smell of overheating wires long before a driver would ever notice. And for food companies, well, it's all about making sure every product is fresh and tastes exactly the same. But okay, moving beyond industry and convenience, this technology is heading into its most profound application yet, using the power of digital smell to completely revolutionize medicine and, yeah, to save lives. This incredible leap is being powered by a breakthrough called biomachine olfaction. Now get this. Instead of just trying to imitate a nose with gas sensors, scientists are now integrating the real thing, actual stabilized olfactory receptors from mammals directly into electronic devices. This gives machines the power to smell with true biological precision. And the results are just staggering. These AI noses are getting incredibly accurate at non-invasive diagnostics. We're talking about detecting Parkinson's from skin samples with over 91% accuracy, identifying tuberculosis from a patient's breath with 95% sensitivity. And they can even find COVID-19 in sweat with 98% sensitivity. It's amazing. Now, to put that into perspective, we have a benchmark we can all understand, a dog's nose. We all know how amazing they are. Trained dogs can detect diseases like prostate cancer with up to 99% sensitivity. That incredible biological gift is the gold standard, and these new technologies are now able to replicate it and maybe even surpass it at scale. So what's the end game? Well, the ultimate vision is to scale this whole thing up, creating a massive network of sensors that could fundamentally change how we interact with our cities and maybe even the planet itself. This whole trajectory looks exactly like what we saw with cameras and microphones. They started out as these rare scientific instruments, then bam, mass adoption puts them in billions of our pockets, leading to uses nobody ever predicted, like the barometer in your phone now being used to detect subtle movements in buildings. Olfactory sensors are on the exact same path. Just try to imagine what this future looks like. A city with a network of sensors creating real-time pollution maps. Drones that can locate disaster victims by their scent, even when visibility is zero. This is the vision of a planetary nervous system, something that helps us manage our environment and respond to crises better than ever before. But, and this is a huge but, this incredible power comes with some enormous ethical questions. We absolutely have to confront the profound privacy risks this kind of technology creates. And this creates a really central conflict. On one side, you've got this immense potential for public good, early warnings for disease outbreaks, faster disaster rescue. But on the other side, the risks to our privacy are just unprecedented. Could these sensors be used for health screening without our consent? Could they reveal deeply personal information, like substance use or even a pregnancy, to corporations or governments? And this concern is very, very real. As the researchers themselves state directly, we have to consider what happens when this technology falls into the wrong hands. It could be used for covert surveillance or even for targeting people based on their unique biological signatures. So this all leads to one final, really provocative question. This technology isn't sci-fi anymore. It's here. As we build a world that can perceive us on a molecular level, we have to decide, when it can smell us back, what are we going to be willing to share, and what will we fight to keep secret?